In this section, we're going to show you how you can log your bash scripts to a log file using a syslog style format. Now, thus far, we've gone through many of the basics in bash. We've written a few scripts, but we haven't effectively logged the output of our script, good or bad, to a log file. Now, bash doesn't support by default any built-in functions which can call syslog, so we can cook our own scenario. And there are certainly other ways of doing this, other binaries that we can call to log information for us, but it helps to know all the bits of pieces of information that we can include within our scripts to create log files that look similar to syslog. The reason why we're aiming for similarity to syslog is that by default, Linux and Unix systems log their daemons using syslog, and there is an accepted format that most administrators understand, accept, and know how to parse. So if our scripts can emulate that sort of logging mechanism, it just makes it easier to read as well as easier to understand. Let's open a shell and navigate to where we've been working all along. That's in the temp2 directory, and we'll see what's involved with logging. In temp2, we have a lot of shell scripts. They're all here, and we're going to pick a few of them to log. But first, before we actually modify any of our scripts, let's examine the typical syntax coming from our syslog files, which are stored typically in /var/log. On a Linux system, you usually will find your logs within var log, /var/log. Here you'll find most of the logs that pertain to the daemons on the system, including MySQL, boot, message, you name it, cron, etc. How about we examine the contents of one of the more popular log files, messages? And also, if you didn't know, within a Linux environment, logs get rotated, and logs without a suffix tend to be the current log. So for example, look at messages. This is the current log file, whereas 1, 2, 3, and 4 have already been rotated, which can be controlled through log rotation. So let's look at messages. We can cat its contents, or we can just head a few of the lines. Let's cat var log messages. You'll see it contains many lines. We can head or tail, alternatively, the lines within this particular log file. So let's clear screen, and we'll head. We'll take maybe the first 2 lines from var log messages. The first 2 lines returns a format that we can aim or aspire towards. What is standard in a syslog file is as follows: a prefix of the month, followed by the day, or the date, in this case October 10th, a timestamp including hours, minutes, and seconds, all of which we can achieve, by the way, the host name where the script actually ran. If you're wondering if your Linux knowledge or Unix knowledge isn't too deep and you're wondering why the host name matters, it's simply because syslog is designed to accept messages from remote hosts. So you could, for example, log your messages from one system to another, one Linux or Unix system to another, using standard syslog. So it helps to identify the host that actually generated the message. Now, we're not delving in deeply into what syslog supports. We do that in the other Linux CBT products, including Debian, Red Hat, etc., including facilities levels, and so on. But we are trying to log in a similar format. The other languages that we look at, Perl, Python, PHP, all have functions which tie into syslog, making it easier to log directly into syslog. But with bash, it isn't there yet, so we can just create a similar environment. After the host name, we have a name of the daemon. Well, in our case, it's going to become the name of the application, followed by the message that we'd like to echo. And in this case, the message that's echoed by the DNS service is such and such. Failure trying to synchronize with .20, maybe .20 was off, or we were unable to communicate with .20, etc. But the basic format is as follows: month, date, timestamp including hours, minutes, seconds in 24-hour time format, which we'll do, host, the service name or the daemon name in our case, which will be the script name, and then the message. So let's try to emulate that format. First and foremost, before we go off writing anything, we should try to find out how we can ascertain or derive the values that you see represented within the script using the tools that are available, the utilities that are available in our Linux system. We should begin with the first column, which gives us, in this case, the month. Now, of course, the first few columns, 1, 2, and 3, can be all derived using the date command. So if we run date with a help option, you'll see various options, various arguments that are returned that we can use to output such a format. Well, let's run that head again. This time we'll take the same 2 lines, and let's just try to see how we'd figure out this information. First, we want the month. So how would we get the month? Well, the month can be achieved using %b. Let's find %b, and that's lowercase b. And here it tells you lowercase %b or lowercase b will return the name of the month, and it's an abbreviated name. If you use uppercase b, it returns the long format, the full name. So we're going to go with %b. So if we were to do date plus %b, it will return oct for October, which is our current month. So we've gotten 1 column. Now how are we going to actually get the date, the 10 that you see here? Well, of course, there's a variable which takes care of it. Let's look in the list again of the available variables. And we have %d. Lowercase d will return with the 0, a prefixed or leading 0, when necessary for numbers 0 through 9, or 1 through 9, that is, the day of the month. So in this case, 01, 02, all the way up to 09, etc. So %d is the next piece of information that we want. Let's put a space and then %d, and now we have October 16th. So we're slowly but surely building what we need. We then need a timestamp in 24-hour format, as you see there. That's quite easy to get as well. It's %t, and that's uppercase T. You find it right here, hours, minutes, seconds in 24-hour format. So you see what's required thus far to build the sort of output, or to create the sort of output that we want. So %t, and of course, as you know, because we've shown you escaping rules, that you need to escape spaces using a backslash. %uppercase T returns the 24-hour, hour, minutes, seconds, timestamp format. So we're well on our way. Next, we need the host name. The host name can be achieved by the hostname command. So we'll simply echo hostname, and then we get the host name. Next, we need the name of the application. Now, we've shown you thus far that the positional parameters store all sorts of information, including the name of the script, which is stored in the first element, element 0. It's stored, by the way, in a variable called pound. And we'll show you that. We're going to set it using the script name. And in fact, we can echo it using 0. So $0 will give us the script name, and then we'll use the base name command to strip off any paths that prefixes it. Next, we'll need a message. The message is what we craft. That's entirely up to us. So for our scripts, we need to craft our messages accordingly. It's entirely up to you. So having said that, let's create our file. We'll create a log1.shell file. It'll begin, of course, with traditional headers. And we'll put author information, date, and we'll also put a purpose, or state our purpose. And our purpose here is to illustrate syslog like logging from our scripts. And we have our traditional end line, which is not required, but I like to put it. So good, we have something to work with. Now let's move on with what we've done thus far. We're going to set the values of what we've just echoed into variables that we can eventually echo using the echo command. So first, let's define a variable. We'll call it myDate. We'll make myDate equivalent to, using command substitution, the date command plus %b escaped space, %d escaped space, and finally %T, which will give us our 24-hour time stamp format, hours, minutes, and seconds included. So myDate's taken care of. Next variable, myHost. Now there's nothing special about the prefix my. We're just using my because it's intuitive. MyHost is equivalent to, and recall within Bash you don't separate your variables with spaces, it isn't permitted. MyHost is equivalent to, again, command substitution, hostname. Let's make use of the system commands that are available. Next variable, myScript. In order to achieve myScript, we can echo 0, but it's better if we use base name space 0. So command substitution, base name, space 0. Otherwise, we'll end up with the full path. In fact, let's show you that. Before we use base name, we'll just get $0. We'll end it with the command substitution backtick. Next, we'll set a variable for my message. My message, and we'll assume that the script will be successful, so we'll just say success. So we have our variables. Now we need to echo them. We'll begin with my date. We echo with a prefix of a $. We'll then have a space and then echo my host, then my script, which you'll see why we need base name in a second, and then finally my message. Let's save this. We'll open a new window doing Control-Shift-T, and we'll need to navigate into temp2. Now if we observe, we have a file called log1.shell. Now if we attempt to source this file without making it executable, look at what happens. We'll source it, log1.shell. Now in this case, the script appears to hang, and it has, because we didn't prefix our MyScript with base name. So we need to say base name here. Now let's kill the script and rerun it. Now it looks great. We have October 16th, etc., Linux CBT serve. Bash is incorrect, but the message is correct. The reason why bash shows up is as follows. The script was sourced, so bash is in the first element of the argument value array. So what we need to do is flag log1.shell executable. So let's change mod u plus x log1.shell. And now let's run log1.shell, and you see it runs nicely. And with base name, it strips the directory prefix. Let's show you what would happen if we were to simply echo this particular variable, because we could simply say echo the $0 variable, and that should return, let's show you, the full path, which you may not want in your script, or you may. Or maybe you want your script, your log file, to contain separate entries, maybe a column for the dir name. Dir name is actually a separate function, a separate binary, which will strip the entire path and produce the directory name. The other programming languages that we examine all have functions to invoke either dir name as well as base name. So what if you wanted a different variable which says my dir name is equivalent to command substitution dir name and of course the name of the script. This will give us the dir name, and then we can echo, before we echo the script, we can echo my dir name. This will give us the directory in which the script ran, and then we'll do my script and we'll use base name, or we could do both of them as separate as one particular string. But if you want to separate them, this is how you should do it. So base name 0, dir name, etc. Now let's take a look. We have the directory as dot, log1.shell as the actual script name. So if we were to go back to, let's say, one directory up, and we specify temp2 log1.shell, then you see that the directory name is temp2. The file name, the script name, is still log1.shell. So we have some information that we can use now for logging. We can put this code into pretty much any script that we use, or source it from any script that we use, and it'll work. It's pretty much variableized. So for example, we could just source, we don't even need the headers. In any script, we can source this particular file by doing source log1.shell, and it'll be included at the level. So you can do an error level check or an exit status check, and if it is good or bad, include this particular script. Or maybe you have one script, log1.shell for good and log2.shell for bad, and you source them depending on the exit status of your script. Right now, however, when we run this particular script, the output isn't being sent to a file. So if we look at our directory, log1.shell is the last newly created file there. Let's run log1.shell again. It runs, it echoes the information to the screen, messages success. However, ideally you should be storing this information into a file from your program. So use redirection, and we'll use append redirection, and we'll send it to a log file which we'll call log1 log1.text, or even log1.log. That's fine, either or. Let's take a look at what happens. It runs, there's no output to the screen, we can echo the exit status, it's good. Now let's lsltr to show us the most recently created entry at the bottom. We now have log1.log, and we can cat its contents, log1.log, and it contains exactly what we want, which is a nice line which looks like a syslog line. And we can keep running this script, it'll just keep populating the log1.log. Let's cat log1.log, it now contains a total of 4 entries. But this isn't as portable as we could make it, so let's show you a better way to do this. What you should do in your script is send the output of your log to a file that gets dynamically created based on the date. That's ideal. No sweat, we're doing shell scripts, so we'll just do command substitution for the output, specify the date, and perhaps you want 1 log file per day. That's usually how it's done, but your default Linux system will ship with perhaps logs that are rotated weekly or even monthly. In our case, let's say we want 1 log file per day. It's no big deal to have 365 or 66 log files over a year. So we'll do date plus %f, which will give us exactly what we want, dot. Now we don't want to call this particular file log1.log because we want this logging module that we're writing to be portable. So how about we make use of one of the variables that we already have? Well, we have a variable called myScript. So we'll just call that variable myScript, and then we'll end with a suffix of log. Now this is ideal because this is portable. Now look at the difference when we create the log file, when we rerun this particular script. It's going to create a new file, and that new file has a prefix of the date, 2004-10-16, log1.shell, which is the name of the script, .log, which means that we can include this particular file in any other script and it'll create what's necessary. Let's do it again. You'll see it keeps appending 2, 3, 4 times, which will create the 5th entry. Now let's cat 2004, and you'll see it creates the entry. Now again, we can include this particular script. It's generic enough to be included in some other script. It's quite possible. It doesn't have anything specific other than the message, which of course we can tailor. But normally you want to log something like success or failure. Now back to some of the scripts that we've already written. We have quite a few of them. We have network checker, move many, etc. Monitor service. We even have the diff, which is somewhere here, the file diff script. Let's find it. We'll do an lsl star.sh. And quite a few of them exist. And here we have backup, bad command, synchronization, hello world, you name it. So how about we modify one of these scripts to actually make use of our newly created log1.shell script? Well, let's see what some of these scripts do. We can do, for example, hello world.shell, and hello world.shell prints this information. How about if we want this information logged to the log file? Let's nano hello world.shell, and somewhere in here we should include the log1.shell. Now here we're sourcing hello world 2. This is stuff we've all done already. But what if we wanted the logging mechanisms? Well, we could source log1.shell, and it'll take care of it for us. And it also could be wrapped within a conditional. So let's keep this in a separate section. We'll just put a comment here which says inclusion of logging module, which contains its own message, etc. Now let's run hello world.shell again. It runs. Now let's do an lsltr, and we now have a new log file because of the inclusion. It's called a prefix of the date stamp, and it's called hello world.shell.log. If we cat it, hello world.2004.hello world.shell.log, it contains generic information, server, directory, name of the script, and the fact that it was successful. Now, of course, you take this a little bit further and you just wrap everything within a condition, such as if the error level, for example, is equal to 0, then you log it. So if we nano our hello world.shell script, now hello world.shell script doesn't really have a reason to fail, although the source inclusion of hello world2.shell could cause this particular log file to, or this particular shell script to fail at some point, simply because it contains an inclusion to a file which must exist on the system. So let's put a little basic logic. If, and you know we do our ifs within brackets, and if it's all on one line, then you do then, followed by the semicolon. So if our error level is equal to 0, then we're happy. If it is equal to 0, then we want to move on and execute the inclusion of our log file. And of course we close with an FI, and we can also alternatively use an else if we had a different file, such as a log2.shell. Let's take a quick look at this. We'll save it, go back to our shell, or to a separate shell. So let's just check the logic. So if the error level is, and this is actually not a string, if it is equal to 0, and we need a space here, then we'll source the log1.shell. This should be fine. We definitely need a space, and we're actually checking an integer value against an integer value. Let's take a look at this. We'll do a hello world 2, or hello world.shell, which includes hello world. And here we've run it, no errors. Let's clear screen, we'll lsltr. And here we have the file, which was just updated. Let's cat 2004 hello world.shell, and it's been populated. Now what if we wanted to alter the script a little bit so it takes an argument from the command line, such as the following? What if we wanted to send the error from the command line instead of defining two separate log files? We certainly could. We could say source log1.shell with perhaps the message, or with a value, maybe 1 for good, 2 for bad. Then we could check for that value in the other script, in the log1.shell script, which will tell us what to do with it. So let's take a look at that. We'll save this. If it's good, we'll send a, and to be in line with the script, we should send 0. So it should be a value of 0. And if it's anything else, such as 1, it's bad. Let's nano log1.shell, and instead of defining the message up front, we should accept the argument from the command line. So depending on what the argument is from the command line, we'll know what the message will be. That's a good way to approach it. So if, for example, and we need to do our logic based on the argument value that comes in. So if the first positional parameter after the script name is equivalent to 1, then the message is success. Else, it'll become failure. So, or whatever else you want the message to be. Then my message is equal to success. Else, my message is equal to failure. And then we'll end our conditional logic here, then actually echo my message. So we set my message based on what we receive from the command line. That's a good way to approach it. So our value is going to be positional parameter 1, if it is equal to, and it is an integer, if it is equal to 0, then it's success. Else, everything else is uncivilized. Let's take a look at this from the shell in terms of setting the message. We're calling it here with a 0 if the exit status is indeed 0. Now it's written to file. Let's lsltr. You'll see that we still have this 2004 file. Let's cat it. And it contains success. Now what if we run hello world with the value of 0? Let's lsltr. We'll cat 2004 again. Still success. Now let's make the changes necessary to hello world.shell. When it calls the log file, it invokes it with an argument, which is always 0. So we need to invoke this with the argument of our positional parameter at position 1, of course, whatever that argument happens to be, so that when we call it, we know what to say. And we call it, of course, from our file. So let's exit this and let's go through the logic one more time. Here we have log1.shell. If positional parameter number 1 is equal to 0, it's success. If it's equal to failure, it's a failure. So we can get out of log1.shell. The focus should now be on the hello world script. The hello world script will accept for itself positional parameters. We need to then say if the positional parameter is equal to 0, call log1.shell with 0 as the option. Else, or we could have done the positional parameter, anything. Else, source log1.shell with positional parameter 1, which is something different. In this case, what it'll do is evaluate whether or not the error level has failed. Now, if the error level is equal to 0, then, but if it's otherwise, then it will fail. Now, that based on whether or not, this is based on whether or not the error level comes back bad or good. We need to create a condition in which this particular file comes back bad. For example, we can source the wrong file. Let's take a look at this. It runs, and we'll cat 2004 hello world.shell. Everything's successful. Now let's modify hello world.shell, and we need to source, let's say, a non-existing file. Let's source hello world 29.shell, and we'll run it from a separate window. Now it's no such directory. Let's lsltr. We'll cat 2004 hello world.shell, and we finally have our first failure entry. So because the last step to run before the conditional check returns something other than 0, we change the way we call the log1.shell script. Let's change this to success position again. This time the file will be included, and we will have success or when we run it. It's run, and now let's cat it. Now we're back to success. We change this to a bad guy. That's 30, which doesn't exist. We'll end up with a failure. Now we have a failure. So you get the picture. So we can call the same log file. Rather than have separate log files write the values first, we can call the same log file in different ways depending on the error status that's returned from the source script. In this case, hello world.shell. You can build this into any script. And it sends over the arguments necessary to log1.shell. Log1.shell makes its decision based on what it receives. Log1.shell simply sets the message. Everything else remains the same. Common denominators in my date, my host, my dir name, my script. But we want to know whether or not the value is successful coming over so that we know what to set in the message. So that's a way to implement syslog style logging in a simple fashion that you can include. It's now modular, so you can include that file using the source specifier in any of your bash shell scripts.